Hey, OChemsters, this is Mrs. Vandalai bringing you the last section of Chapter 6 OChemster video. So I know that this is a lot of information to keep SN1, SN2, E1, E2 straight in your head. So we're just going to see how substitution elimination sometimes work in competition, how you can, again, figure out which one is which, okay? So let's start off first with tertiary halides. Substitution, you're going to only occur in SN1. Elimination can either occur by E1 or by E2. So it will depend on the nucleophile. So letter B, if there is going to be heat involved, which I like to include, your strong nucleophile, probably your negative ion, your anion, if you will, your strong base, will favor E2. All right. And again, I'm going to try to keep this as simple as I can. I've already said before that in college they'll probably throw at you each type possible, but I'm going to try to keep it very consistent as far as I go. If you have heat, you're going to automatically know it's going to be elimination. You know you're going to have three products. You know you're going to have a double bond. If there's no heat, it's a simple swap. Okay, so that's how I look at it. Again, the other thing I'm going to try to keep very consistent is that if I want it to be SN2, I will have a primary or secondary with a negative ion. If I want it to be SN1, I'll have a secondary or tertiary with a neutral base, okay? If I want it to be E1, I'll show you the heat, and I'll probably have a weak or a neutral nucleophile. If I want you to use E2, I'll have you use the heat and a strong nucleophile. So I do have something at the very end that kind of puts that all together. But again, I am trying to keep things simple, and we'll try to be very consistent. In college, I don't know what your professor will do there, okay? All right, so let me show you what I'm talking about down here. All right, so here I showed you a substitution reaction. Notice I have a tertiary substrate, and then I have a weak nucleophile. There's not a charge with it. It's a methanol, as I put here. And what I did also is notice that this is a neutral nucleophile. This is a neutral substrate. So I get a positively charged organic product, and then the bromide ion is my leaving group. I could also at this point take off an H plus to get the just an O and a C, but for this I just left it there. But again, notice neutral plus neutral makes a positive and a negative. Why is it SN1 again? Because it's primary, or sorry, it's tertiary. You will not see SN2 being tertiary. It's also a weak nucleophile. So what about elimination? All right, this is once again, you have to worry about, oh, this should be a beta, by the way, your beta hydrogen. Let me fix that right now, actually. Hey, OChemsters, this is Mrs. Vandalai bringing you OChemster video 6.8. This is, again, trying to put everything in perspective of how do you know if you have SN1, SN2, E1, or E2. I'm trying to keep it simple. I know I've already said this before, but colleges may not. So when you go back, and I hope you bring your notes with you if you take organic chemistry in college, that I am making it very simplistic. Your college professor may not, okay? So how do you know when you have it? Let's kind of recap what we've done so far. So once again, I'll say it once again. This is Mrs. Vanderwaal making it simple, okay? Your college professor may make it a little bit more difficult, okay? But in general, SN1, SN2, you aren't going to see heat. E1, E2, you will, okay? You can also play around with the solvent. I'm not going to do that, okay? We're looking at the substrate, either a secondary or tertiary in SN1 and E1. Primary and secondary for SN2, E2. What else? The weak nucleophile, probably neutral for SN1 and E1, strong nucleophile for SN2, E2. And again, it doesn't have to be this way, as we're going to see shortly, but that's what I'm going to do. So if I give you a test or a quiz, this is what you will need to know for me. What I'm telling you isn't incorrect, but it's not the complete picture, okay? All right. So let's talk about the tertiary halides, okay? So in substitution, they can only occur in SN1. If you think about the mechanism, that makes sense, okay? In substitution for your SN1, you wait for the leaving group to leave first, all right? Why? Because the tertiary is too bulky, the nucleophile can't approach it, okay? Elimination, if you think about how elimination can occur, the mechanism, they can actually occur by either E1 or E2. Now, folks, like I said, all right, I'm not going to do that to you, but this is your reality, okay? So in college, they may give that to you. It will depend on a strong nucleophile or a weak nucleophile. So the strong, once again, favors the E2. So you have to look at that. Once again, I will always give you your clue that you're going to have heat if I want elimination. So let's take a look at these two side by side. Remember we said substitution can only occur, tertiary can only occur with substitution SN1. So here I have it. So here's my tertiary substrate. Notice the central carbon has 3 carbons off of it. And notice I have a weak nucleophile. What I want to show you real quick, if you go back and look at your first page again, I want to drive this home to you. If you have a neutral substrate and a neutral nucleophile, your organic product is going to have a positive, all right? Why? Because your leaving group must be negative. So what does that mean? What have I shown you before? That H can come off, all right? And so then you'd have a neutral, the OC there. It's actually an ether group, but we haven't learned that yet. And then you'll have an H plus, but I just didn't do that here. I just still want to show you neutral makes a positive and a negative, okay? So about the elimination, well, I just kind of showed you the E2 mechanism, okay? So this is what I probably won't ever do again to you. I'm just showing you it can occur. So here is my tertiary, there's my beta hydrogen. Now I have a strong nucleophile plus heat, that's your clue, it's elimination. The strong nucleophile is your clue that it's going to be an E2. And again, do you remember what this is called? A dehydrohalogenation. So what 2 things are going to leave? Your hydro, all right, it ends up going to the base to make water, and what else leaves is your halogen, your bromide. So what do you have in the place? Remember those electrons right here, those electrons are going to swing down and create the double bond, and you'll have 100% of this product. In reality, you're probably going to have a mixture of this product and an alkene, but not necessarily. I'm not going to ask you that, okay? So what about a primary halide? Again, only SN2 and E2 mechanisms are possible, okay? Again, why? Because you have a strong base that's going to kick out that leaving group, okay? So it says in order to ionize the primary carbocation, the first step for E1, E2 does not occur. It does it on its own, okay? So with most nucleophiles, the primary halide will give mainly your substitution products, okay? But only with a big, bulky, strong base. In this case, what we see in E2, okay? So your primary. So let's check it out, all right? So here I have, this isn't truly a huge bulky base, all right? It's just ethoxide. And so most of the time I will have the SN2 where I just swap it out, but you might get a little bit of E2 in there, okay? So about 10%. Again, what will I want? Notice I didn't even put any heat in here, so I want you to go with the substitution, okay? So here is my elimination. Notice that this is bigger and bulkier. I made it a tertiary nucleophile for that respect. So you're only going to get an E2. So you're only going to get the double bond, the bromide, and then here's your nucleophile with the H plus with it, okay? So that would be primary. So what do you think my next page is all going to be about? Yes, what do we do about secondary? Well, let's find out. But what about your secondary? Well, guess what? All 4 mechanisms are possible. So again, it depends on the strength of the nucleophile and the reaction conditions. And for me, the temperature is going to be a huge clue. Substitution is favored with stronger nucleophiles that are not bases, weaker nucleophiles such as polar solvents, and elimination is favored by your stronger bases. All right, so let's see how I work this out. So notice here I have a secondary substrate, and I have a strong nucleophile that isn't really known as a base. With the sulfur here instead of an oxygen, it's not really a true base, but it is a strong nucleophile because of the negative. All right, so then it is a pure substitution, SN2. All right, well, what about my next one? I'll scroll it down a little bit. Okay, so notice here I do have a weaker nucleophile, and this is very consistent with what I've been telling you already. All right, so here I have this again a substitution, and it would have been a positive product. So this H was originally hooked here as being a positive product, but I took it off. All right, there's your SN1. All right, notice here. All right, I have heat. I gave you that. There you go. And I have a big, strong, bulky base. Notice I have an oxygen again, and it's very bulky. So there is my E2. Notice I have my double bond, and then I also have 3 products. And then what about E1? I gave you that too with heat, and I have a strong base. Okay, so that would be a secondary and a strong base with heat. Okay. Again, I'm going to try to be consistent, but that's kind of like how it goes. So let's try this. Predict the product of the reaction of 1-bromo, 1-methyl cyclohexane with, all right. So letter A, I want you to include heat. There you go. So if you recall your Leah video, she's also talking about the solvent. Well, it will help stabilize, as will the heat. Okay, so but I want to put heat there so you know I'm thinking of elimination. And you can kind of see right here a little clue that we have to worry about your beta hydrogens. Okay, so look what I did here. This is a tertiary. All right, here's my ethoxide, kind of a strong base there, plus heat. Notice I have 2 choices and where the double bond can go. All right, so if I eliminate the red hydrogen here, the red beta hydrogen, I'm gonna have a double bond with this carbon, and this hydrogen stays put. But what if I want this beta hydrogen to leave? All right, this is my product. Don't forget you dehydro, so it goes over here, dehalogenation, the bromine leaves, and I have an alkane. So my question to you is, all right, so which one is more likely to be my product? So think about that, okay? What are you going to get? The second one. Yes, that is right. Why is it? It's your more substituted group, okay? So you're going to get more of the one I circled and less of the one I didn't circle. Not to say I'm not going to make any. I will make some, but I'm going to make a whole lot more of this one, okay? Try the next one. I just want ethanol, which is also no heat. Oh, it's going to be a substitution. So if it's a substitution, folks, what kind of a substrate is this? Here's this carbon. How many carbons are hanging off of this carbon? 1, 2, 3. It's a tertiary. I have a tertiary and a weak nucleophile. What's it going to be, everyone? It's going to be an SN1, okay? So I have, you can see, here's my tertiary, here's my ethanol. So I'm going to make this plus the bromide. So what else do you think I did at this point? I don't like, oops, sorry about that. I don't like having a positive like that. So I took off the H plus, all right, and here. I've already told you this before. If you want to stop with this product, be my guest. If you want to take off that H plus, because it will come off, be my guest. But again, I'm showing you this because I have neutral and neutral. So make a positive and a negative. It works out here. Neutral plus neutral equals a neutral plus positive plus negative. It still works out, okay? So that's it. Don't wait to be great. We'll see you next time. I hope this helped. Bye-bye.